Hello there, welcome back. And this time we are going to understand how to model a digital logic buffer using Verilog. In our previous model, we understood the concept of modeling an inverter circuit. So you see that this is an inverter circuit using the CMOS transistors, and this is a symbol for the inverter. And we said Y is equal to the complement of A. Let me write here in a proper way. Y is equal to complement of A. But now in this model, we will understand how to model a buffer circuit, not an inverter. So basically, this is a symbol for the buffer circuit. As usual, you have an input A, you have an output Y, but here the output is not a complement of input, rather it is equal to input. So whenever this circuit is activated, your input gets connected to the output. Okay, so if it is logic 0, output will be logic 0. If input is logic 1, output will be logic 1. So how to write the code for this? So as usual, we have two types of modeling technique. One is data flow for the buffer circuit, and one is gate level for the buffer circuit. And so how to write? The code starts from here to here in both cases. So as usual, we say we use the keyword module and we use end module. So these two are fixed, okay? And in between we have a code. So after writing the keyword module, give a name to your circuit. So I say it is buffer, okay? Or you can give any name. And then in the parentheses, I define my output and the input. So obviously I have single output wire, I have single input wire. So Y comma A, don't forget to put this X semicolon at the end of this. And then I say output Y semicolon, input A semicolon. And the most important part is this, use this syntax. I use the keyword assign where output is assigned and input A here. I don't need to use this parenthesis here, okay? I can simply write Y is equal to A and then semicolon. So you have that. And finally, end module. So that's it. You finished your code for the buffer circuit using data flow modeling. How about the buffer, writing the code for the buffer using gate level? So as usual, write the first keyword module and the end module, and in between you write the code. Give a name to your circuit. I give it buffer. In bracket you have Y comma A, and that's it. Okay, close the bracket and then semicolon. Then say output is Y semicolon. My input is A semicolon. But now look at this special primitive that we have used. So in Verilog, you have, for the gate level modeling, you have variety of primitives such as AND, OR, NOR, NAND, XOR, XNOR, buffer, tri-state buffer, etc. So I am using one of the primitive called as buff, BUF. So that means I am instantiating the buffer by calling this primitive. So I'm just using this the primitive there. So I'm just instantiating that gate right over in my code. So my code will pick up that primitive and it understand that, okay, and the gate is G1. And then in bracket, I define output and the input. So output is Y, input is A. But here you have to make sure the output always precedes the input. You cannot write A comma Y, that input and then follows the output. No, your output has to be in the beginning. Here you can manage that. You can write any. Here also you can write input first and then output second is okay. But here when calling the primitive, you basically say that. So okay, so I say buff gate 1. So this is just a logic gate I'm calling, and in bracket Y comma A. Now what is this? So in our previous model, right over here, we have understood that this is a logic circuit will be implemented using transistor. So it has got a propagation delay called PD, propagation delay. So I am saying it has got propagation delay of 10 time steps. So that time steps could be nanosecond or picosecond. So I need to define at the beginning of my code if I decide to use the delays, specify the delays in my code. Okay, so it means when I switch from 0 to 1 or 1 to 0 at the input, it will take me 10 time steps to reflect the change from 0 to 1 or 1 to 0 at the output. So that's how it will work. Okay, so I hope you understood the concept of buffer and how to model it using Verilog. Very simple. So for example, this is your CMOS circuit and you will have this circuit like this. So you see that I have got this CMOS circuit, input is A. Here, the output Y is equal to complement of A. This is my VDD and this is ground. But this is an inverter circuit. I want a buffer circuit. So what I'm gonna do, I'm going to do add another circuit as a CMOS inverter right over here. So what this is my circuit. So this is VDD, and then I have got this is ground, and right over here I have used another input. But now the input here is complement of A and the final output will be again complement of A bar, so which will be A. So just have two CMOS inverters in cascading to get Y equal to A. So this is how the buffer circuit will work. I hope you found this video useful. If you did so, share it with others and for wider reach, and stay tuned for more engaging contents like this. Soon we are going to introduce a behavioral modeling of the logic circuits. And one more important point is that we have a membership offer now. So some of our videos are exclusively for the members. So if you are interested, you can explore those. And one more final point, you can support our initiative using by clicking on the thanks button on our modules. Okay, so search for the thanks button and clicking there if you are interested, and we would have that motivation to produce more contents like this. Okay, so stay tuned for more engaging content. Until then, wish you happy learning.